stop music. For those of you on live stream, I'll put in your slides, if that's all right. I think you said the link earlier. So you'll get a better, high resolution version of the slides. But yeah, ask any questions in the chat and stuff. So I first saw this same talk that Ollie gave last year, and I thought it was like, I found it really awesome. Like I really got a lot from it, and I really, enjoyed the topics that you talked about. So, and I thought it'd be like really great for JS Oxford, and also I think there's a lot of things at Oxbotica that we could learn from the topics that Ollie's going to share with us. So yeah, thank you very much for coming here as well. Like I really appreciate it, and yeah.
Thank you. Yeah, my name's Ollie. It's a pleasure to be here. Thanks, Ben, for asking me to speak. I thought probably a little bit too late in the car on the way over here. The last time, when I wrote this talk, put this talk together, it was targeted at kind of a more generalist audience, so an audience that had, I'm making a lot of assumptions here, but had kind of designers, content designers, sort of hobbyists, people just generally interested in sort of web space in it. I'm assuming, as this is called JSOxbotica, that it's going to be quite developer heavy. Is there anyone here that's not a developer?
Me.
Wouldn't count. Cool. So the talk is, I guess, intentionally quite light on like really technical stuff. So if there's anything you want to know more about, feel free to ask questions at the end. But let's see how it goes. So I'm a developer and I work at an organisation called the Government Digital Service, or GDS for short. GDS is part of the Cabinet Office, which means as well as being a developer, I'm also a civil servant. And today I would like to talk to you about how we build government services that work for everybody, services which are easy to use, inclusive and accessible. Before we start, I thought I should tell you a little bit about gov.uk, which is the website for the UK government, and explain what I mean by a service. So GDS builds and maintains www.gov.uk, which basically hosts the content. So policy, announcements, information about the government, guidance for citizens. For example, you might use it to find out when the next bank holiday is, how to set up a business, or other normal everyday government things like how to report treasure. Gov.uk also brings government services together in one place. So services might be things like register as a childminder or view and share your driving license. And these services are usually built by service teams within one of any of the 25 government departments. It's big and sprawling enough that no one I've asked actually seems to know how many there are, but there's at least 750. And between them, they handle billions of transactions every year. So I work on the gov.uk design system, which is designed to help thousands of individuals within those service teams build things that look and behave like gov.uk and like each other. For example, provide styles, so typography, headings, lists, tables, links, things like that. There's also reusable interface components, so button, form inputs, or the error summary. And then there's also patterns. These are best practice design solutions for specific tasks and page types. Things like how to ask a user for their name. Working as part of the design system team has given me a lot of opportunities to learn about accessibility and inclusion. I am no accessibility expert, but it's something that I've come to care about, and I'm lucky enough to work at an organisation that prioritises it. Government services have to work for everybody. If an e-commerce site isn't accessible, it's obviously not great, but in most cases, an individual who faces barriers using that site can choose to take their custom somewhere else. If a government service is inaccessible, the user generally has no alternative other than potentially moving to offline channels like phone or face-to-face, or relying on friends or family to assist. And although the design system has only been in beta for maybe 18 months now, we're both starting from scratch when we built it. We tried to capture the existing decisions and the knowledge wrapped up in the existing tools that teams are already using. The work of hundreds of individuals across government, built on top of best practices established within the industry and further afield. GDS has been around since 2011, and gov.uk went into public beta in January 2012. So I figure the stuff I'm going to talk about today is the result of kind of at least 8 years' work. And during that time, we've learned and we've iterated, and we've tried to make gov.uk more and more accessible, one change at a time. And the reason I think it's important to tell you this is because there's a lot of stuff in this talk, And I don't want you to go away kind of intimidated thinking that, how am I ever going to do all of these things? That's not bother. Whatever you're building, as accessibility engineer Leonie Watson has said, doesn't have to be perfect, just a little bit better than yesterday. So around GDS, we have a lot of stickers on our laptops, and this is one of them you might see. Make things open, it makes things better. And it's kind of with that spirit that I wanted to share some of what I've learned about making websites that are inclusive and accessible. So in order to do this, I'd like to walk you through a fictional service. This isn't real, that was built using the styles, components, and patterns from our design system. We've got another tool called the Prototype Kit, which designers across government use to build prototypes of services. When we train users to use it, we use the example service applied for a juggling license, and it seemed kind of fitting to use that here as well. We call this page the start page, and its purpose is to help people understand what a service does and whether or not they need to use it. The first thing we should look at is how a service is named. So a service should be simple. It should help the user to achieve something, like learn to drive, buy a house, or become a childminder. It's an activity that needs to be done, and so it makes sense to describe it using a verb, not a noun. In the past, services have been seen as discrete things that need to be completed in a particular way, so we've described them using nouns. For example, the statutory off-road vehicle notification, or SORM, for declaring a vehicle is no longer on the road, or RIDOR, reporting of injuries, diseases, and dangerous occurrences regulations, 1995. So if we named our juggling license in the same way, we might come up with some clever acronym, maybe juggling under government license, or JUGL, apply for a JUGL. The problem with naming a service like this is that you need to know what name government has given the thing that you're trying to do in order to be able to find it. So instead, we try to use simple verb-based names that align with the goals of the user. Things like register to vote, which was originally known internally as the Individual Electoral Registration System, get help with court fees rather than fee remission, and verify, which started out as the Identity Assurance Program. Within our service, we use headings to communicate the structure of each page. The most important heading on the page is an H1. In this case, it's the name of the service. There's an H2 further down with the text more information. Web browsers, plugins, and assistive technology can use these headings to provide navigation. As well as making it easy to navigate, users can use this functionality to get an overview of what content is on the page. So this is the headings rotor from VoiceOver, which is a screen reader built into macOS. And you can see how it shows all of the heading on the page alongside their levels. So if you're not able to, if you can't visually see the page, you can't kind of skim read it. So this is kind of the next best thing. So moving on down our start page, let's look at this button, which is not actually a button at all. It's a link that's been styled to look like a button. The reason we do this is because we want a prominent and consistent call to action across all of the pages in the service to make it really clear to users what they should click to progress. When the call to action is sending data to a service, it makes sense for it to be in a form and therefore to use a button. But on the start page, we're not sending any data, so we want to use a link, but we still want it to be prominent and visually consistent with all the others. When something looks like a button, it's reasonable for users to be able to interact with it like it is a button. For example, if you were using dictation software, you'd expect to be able to say things like, click the Start Now button. We can use the role attribute to tell assistive technology, like screen readers and dictation software, to treat this element as if it was a button. But this isn't enough, because buttons behave differently to links. As an example, users may well have learned that you can trigger buttons using the spacebar, which isn't something you can do with a link. It just scrolls the page down. Even if you weren't already aware of this, now that we've the button role, some of that assistive technology will tell you can do it. So a screen reader might announce, Start Now, button. To activate, press spacebar. Unfortunately, pressing the spacebar doesn't activate links, and that's not fixed just by adding the button role. So finally, some JavaScript, possibly the only JavaScript in the entire presentation, and it's not even that exciting really. This is something that we have to take care of ourselves. So this code ensures that if someone presses the spacebar, whilst they're focused on a link, that has the button role, then we act as if they click the button. There's one other difference between links and buttons that came up during another team's user research session. So that they observed that button clicks weren't being registered correctly with this particular user because they were moving the mouse as they were clicking, and this was being interpreted as the user trying to drag the button. You can imagine this might be particularly problematic for users that have mobility impairments, such as hand tremors or other kind of difficulty with fine motor movement. This is only a problem for our links that are styled as buttons. For reasons I do not understand, native buttons don't behave in this way. So they contributed a fix that adds this draggable attribute and sets it to false, which, as I suspect you can work out, stops the button from being dragged. The button's highlighted in yellow, which we use to show which element currently has keyboard focus. This is really important for users who use the keyboard to navigate the page, as it lets them determine what they're currently interacting with. The focus state is actually something we spent a lot of time on last year and ended up changing. So it used to be closer to orange and a lot less obvious. We changed it because although the black text contrasts well against the orange, we found that the orange did not have enough contrast against the page background. This meant that we weren't meeting your accessibility guidelines and that some users may not be able to see it. We tried to find another color in the same part of the spectrum, but always ended up with this muddy brown color. So although this is technically compliant, it's a lot worse in terms of the text contrast, so we thought we could do better. We built a tool to visualize all of the colors within a given hue that meet both contrast requirements. And as you can see, this kind of really limits your options to a narrow part of the color spectrum. So we experimented looking at colors in the pink part of the spectrum, but they didn't really fit with the rest of the brand, and they still didn't meet contrast when they were used on darker backgrounds. So we looked at other approaches, things like adding borders or reversing colors, full color inversion, offset borders, double borders, dotted borders. Eventually, we found something that we thought worked, using a combination of bright yellow and black. Because it always uses a light and dark color together, it should meet color contrast requirements, whether it's on a light background or a dark one. So for links and things that look like links, as well as using this brighter yellow, we add a solid black underline. Form inputs use the bright yellow outline, but the black border gets thicker when they're focused as well, like this. And we use that same technique for radios and checkboxes. This seems like a simple change, but it's been surprisingly complex to roll out. So some components, like this accordion, needed more fundamental changes. We used to outline the entire focus section, but we found that highlighting the entire thing in that bright yellow color was way too overwhelming. So now we just highlight the text within it. So that was page one, the start page. We've looked at naming your service using simple language and with verbs, not nouns, using roles in JavaScript to make things that are visually similar behave consistently, and having a clear and consistent focus state for interactive elements. So we can now click on our surprisingly complicated button and move on to the next part of our service, where finally it's time to ask the user for some information. On this page, we're asking the user whether they've held a juggling license before. Before we can dig into that, we should take a closer look at the backlink at the top of the page. So we include this link because we know that lots of users have learned to distrust the browser's backbone, as it can often do unexpected things, like cause them to lose their progress, or it can just error. The backlink includes this arrow, a small backwards pointing triangle, and it's the same icon typically used for the browser's backbone. Rather than using an image for this, we create the triangle using CSS. So to demonstrate how this works, imagine a square with a thick border around it. If we make each side of the square a different color, we can see that the edges meet at 45 degrees. If we give this square no height and no width, but really thick borders, then those 45-degree angles create 4 triangles pointing towards the center of the square. We can then pick the side that's pointing in the direction that we want and make the other 3 sides transparent. However, we know that some users choose to override the colors that websites use by changing their browser settings, enabling high contrast mode on Windows, or by using a browser extension. They may do this to increase or decrease the amount of contrast on the page, or so that they can use specific color combinations that make it easier for them to look at the screen or to read the content. So these tools allow users to change the color of the background, the text, and the links. In this case, it's also important to know that any borders on the page are often overridden to use the same color as the text. This includes the transparent borders, which become visible again. So instead of seeing a triangle, users end up seeing a square, which is not quite what we were going for. So to try and fix this, we can use another CSS property called clippath. This allows us to draw a shape using coordinates, and only the parts of the element within that shape are visible. So in this case, we use it to draw a triangle that matches with the triangle created by the borders, which then looks something like this, which is more like it. Clippath is a relatively new CSS feature that isn't supported by older browsers. So this is why we combine both techniques together. Even then, it will only look like a triangle for users who change colors if their browser supports clippath. But because of that, we have an issue in our backlog to explore other options. Perhaps, maybe we should just use an image. So with that out of the way, we can turn our attention to the rest of the page. There's not much on it, aside from the header and the footer that appear everywhere. There's the question, 2 radio buttons labeled yes and no, and a button labeled continue. When it comes to structuring forms, we start with one thing per page. We found this makes it easier for users to understand what you're asking them to do and to focus on the specific question and its answer. Like we saw on the start page, the question acts as the main heading, but we need it to play another role as well. It needs to be associated with those yes and no answers. Otherwise, if you focused on one of the radio buttons whilst you're using a screen reader, all you would hear would be yes or no with no context. And this would be even more important if there were other questions on the page. It might be easier to see how this works if you take away all of the gov.uk styling. So we've got the 2 radio buttons. Each one has its own label. The label is associated with a specific radio button and represents the answers to the question. Those radio buttons are grouped together inside a field set, and the field set has a legend, which is the question that all of the radio buttons answer. To allow the question to perform both of these roles, we used to include the question twice, once as the heading, and then again as a legend, but a legend that was only visible to screen readers. However, this meant that in some cases, the screen reader user could hear it 3 times to navigate through the page. So firstly, they would hear the heading, then the otherwise invisible legend, and then when they focused the first radio button, they would hear the legend for a second time. In the end, after a lot of testing, we put the heading inside the legend. Problem solved for now, but I'm going to come back to this later. So what about the radio buttons? These are not the browser's built-in radio buttons, these are custom. Early in the development of gov.uk, we observed in research lots of users clicking on the radio button or the checkbox controls rather than on their labels, despite the fact that the labels are so much bigger and easier to click, especially for those users who have difficulty with fine motor movement. We think that this was because users didn't know whether or not they could click the labels. There are plenty of examples of poorly implemented radios and checkboxes on the internet, where the label is not associated with the radio button or the checkbox, so clicking on it doesn't do anything. And so users have learned to always click on the control, because it always works. We thought that adding these grey boxes around the controls would make it clearer that you could click on the labels, but we still saw users fighting to click on the controls. We tried just making the controls bigger, so this would be easier, but unfortunately, the huge variation in the way that browsers handled this meant this wasn't feasible. In some browsers, it just wasn't possible to resize them. The controls stubbornly remained the same size regardless of what we did to try and style them. In others, making the controls bigger made them really blurry or pixelated. And in some cases, they scaled in really unusual ways. On older versions of iOS, radio buttons became square and started to look an awful lot like checkboxes. So this led us to create custom styles for these controls. But it wasn't a decision that was made lightly, and a lot of work went into assuring that they worked just as well across all of the browsers and assistive technologies we supported at the time, including, of course, making sure that they work just as well for users who choose to change colors change the colors that websites use. So it's page 2. And we've looked at using clip paths to better support users who change colors in their browser, how starting with one thing per page helps the user to focus on the task at hand, what to do when the question on a page needs to perform multiple roles, and why we have custom radio buttons and checkboxes on Gov.uk. Let's move on. We're going to assume that we definitely have had a juggling license before, and the next page in our service is asking us for the details of that previous license, the license number and its expiry date. You might imagine an alternative where the form is laid out horizontally with the labels on the left-hand side of the screen and the inputs on the right. However, this requires the user to scan both top to bottom and left to right, whilst maintaining those associations in their head. Placing the labels directly above the fields means that the user can just scan down the left-hand side of the page and still understand what they're being asked to fill in. It also makes the relationship between the label and its input really clear, and it works better when labels are long or we need to provide hint text. Requiring the user to only scan in one direction is particularly important for users that zoom the screen to really high magnification levels, as they don't have to try and zigzag across the screen in two directions. When it comes to asking for the expiry date, it's probably more interesting to list the things that we're not doing. So we're not using a date picker because the user already knows what date they need to input. They do not need access to a calendar to understand what day of the week it expired on or to choose from a limited set of dates. We do provide an example of the expected format as a hint so that users understand how to enter it. We're not using drop-downs because in user research we've seen that some users can struggle to use them. And we're not automatically moving the user between fields because that can confuse users who cannot easily perceive the fact that the focus is moved. If we go on to submit the form without filling in a required field or having made a mistake, the service needs to be able to communicate this back to the user so that they can correct it. We want to help the user understand what's going on as soon as possible. They're expecting to have moved on to another screen. So the fact that they've been presented with the same screen with errors could be quite disorientating if it's not made clear. We use this, the error summary component, at the top of the page to tell the user that there is a problem. We focus it when the page loads, which is why you've got the yellow outline around the box, and we give it an alert role. This means that most screen readers will automatically read out, there is a problem, before anything else, informing the user that they need to correct something. Unfortunately, we found that in some combinations of browsers and screen reader, this didn't always work, so users could be left unaware of the validation errors. For many screen readers, the page title is the very first thing they read out. And so adding error into the page title gives us one additional way to let the user know what's going on. Within the error summary, we provide links to each of the errors on the page. But which element on the page should these links actually take you to? We did lots of research into this. You know it's serious because there's a spreadsheet. And we tried out loads of different options whilst using different assistive technologies. We tried linking to the input, to the label, and for questions that use multiple inputs, like the date input, linking to the field set or to the legend. We found that linking directly to the first input provided the best experience. But if you link to something that's not already visible on the screen, the browser's default behavior is to scroll it, so it's the very first thing at the top of the screen. And in our case, because we're now linking to the input, the label and the hint end up off the top of the screen, unable to be seen. We're able to fix this by adding some JavaScript that handles clicks on those links, scrolls to the nearest label while still focusing the input. We add a red border to the left of the field. This helps the fields that have errors to stand out, but also means that we're not communicating the fact that there's an error using color alone. We use simple, non-technical language to explain the error, and we use the same error message that we used in the error summary so that users can be sure that they represent the same problem. We associate the error message with the input as an extra description with an additional error prefix that's not visible, but will be read out by screen readers. This means if you're using a screen reader, when you focus the input, the label and the error message are both read out to you. So it might say something like this: previous license number, edit text, error, enter your previous license number. On this page, we've looked at making sure users can understand how labels, hints, and inputs relate to each other, how we ask for dates that the user will know, and helping users understand when there's a problem with the way they fill in a form. On the next page, we're asking the user what their most impressive juggling trick is. Once again, the question on this page is performing two roles. It's the page heading, but it also needs to be associated with that text box. Because there's only one field, there's no field set or legend on this page. The question is just a label. So presumably, we should put the heading inside the label. Of course, nothing is ever that simple. Whilst it's valid to put a heading inside a legend, according to the HTML spec, it's not valid to put a heading inside a label. Initially, we tried to contribute a change to the spec here because that didn't seem right. But the folks at W3C gave us some quite sensible reasons why it shouldn't change. So in this case, we do the opposite and put the label inside the heading. This stuff is really confusing and it's hard to get right. It's hard enough that we ended up writing a whole separate guide dedicated to it, making labels and legends headings. We provide a text area for the user to fill in their answer. In our fictional service, we know that this field is going to be reviewed as part of the application process. So to discourage users from providing their entire life story, we use a character count on this field to limit the length of their response. So after the text area, we include a message. You have 200 characters remaining. As the user types, the number of characters remaining goes down. Once they've reached the limit, it's getting darker and darker. Don't need to dance around a bit. The field is highlighted in red, and the message changes to tell the user that they've entered too many characters. But if you cannot see the screen, you won't be able to see this feedback. To make this information available to other users, we can use another ARIA attribute, ARIA Live. By setting ARIA Live to polite, whenever the user stops typing, the remaining character limit is announced, which in practice works like this.
Press a juggling trick, edit text, name, I, you have space, A, N, you have 195 characters remaining, space, J, U, G, G, L, E, you have 188 characters remaining, your space, L, E, A, T, H, E, R, space, S, O, C, C, E, R, space, B, A, L, L, S, period. You have 166 characters remaining.
Cool. So on this page, we've looked at how making a question into a heading works differently depending on whether the question is a label or a legend, and how we can make a character count accessible to visually impaired users by using the ARIA Live attribute. Towards the end of the service, we sometimes use a page that we call Check Your Answers. It looks a little like a table with each row representing a question from the service. So in the first column, what the question was, for example, name. In the second column, the answer that the user gave. And finally, a link to change their answer. We use this page to increase users' confidence, as they can easily see they've completed all of the sections and that their data has been captured correctly. It also gives the user a second chance to notice and correct errors before submitting forms, reducing error rates. On mobile, the layout changes. We collapse the table into a simple list of questions and answers with a change link underneath each one. The same layout gets applied if the user zooms the page in their browser. And similar to how we always put labels above inputs rather than next to them, this allows users who need to use a high magnification level to easily scan down the page without having to move left to right. Every link uses the same text, they all just say change. Because they're all visually associated with a question by the fact they're in the same row, for a visually sighted user, it's easy to understand what each link is going to do, even though they all have the same text. But if you are navigating the page as a screen reader user, or asking a screen reader to list all of the links on the page, this context gets lost. All you see is a list of links called change. To fix this, we include the question name as visually hidden text. Screen readers can see this, but it's not visible on the screen. So now, rather than all 4 links just being labeled change, we get that context back, change name or change date of birth. On this page, we've looked at adjusting the layout on mobile, and when users zoom into a high magnification level, to provide a better experience, and adding visually hidden text to help users differentiate between links. The last screen in our fictional service is the confirmation page. And the downside of the format I chose for this talk is there's not much to say about it. But we do need to make sure that it's totally clear to the user that they've done everything correctly, they've finished applying, and what's going to happen next. That's why we use this very prominent green panel at the top of the screen, where we tell the user that their application is complete. But if a user has chosen to change the colors in their browser, this background gets removed and the panel loses its prominence. We can take advantage of that one thing that tripped us up earlier, the fact that transparent borders become solid and colors are overridden. If we add a thick transparent border around the panel, this becomes visible when colors are changed, which gives the panel its prominence back. And that brings us to the end of our service. Hopefully, no matter our circumstances, we've been able to apply for a juggling license. We've touched on a lot of different things going through this service: content design, interaction design, front-end and back-end development, and service design. If we were building this service for real, product managers would need to know to prioritize this work. QA testers would need to know to look for it. I think this is a really good example of why accessibility is not one person's job, and also why it's something that can't be added in at the end of the project. It needs to be part of every decision that gets made, involving every person from every discipline. I think it's about consciously choosing to take the path that removes friction for users, rather than introducing barriers, even when that path may be harder. It's also one of the reasons that I'm really excited about the benefits that building with components, with a design system, can bring to an organization. The design system isn't magic. Without due care, it's still entirely possible to use it and build something incredibly inaccessible. But by baking a lot of this stuff in, we save teams from having to make these same decisions over and over, allowing them to focus on the things that are unique to their service. In putting this all together, I pulled information from loads of different blog posts and from previous talks and pull requests and issues from GitHub. Cannot overstate how little of what I've talked about is work I can take credit for. A lot of it is the work of these lovely people and many others. I've published a blog post on my site that links out to all of those various blog posts, pull requests, issues, and documentation. You can find it at obyford.com/inclusive. If you want to check out the design system, you can find it at gov.uk/design-system. All of our work is also in public repositories on GitHub. There's 3 main ones. Gov.uk frontend, which is the code that teams use to build services. The design system itself, which is basically the guidance. And there's also a community backlog where there's lots of interesting discussions going on within issues about our components and patterns, both new and existing. And that is it. Thank you very much. Questions?
If you're happy doing questions, I'm
Does anyone have any questions? Because if not, that solves that problem.
I have one.
Yeah.
The triangle on the back button, you use the borders, but also the clip path.
Yeah.
Because the clip path would only display whatever is inside the clip path.
Yeah.
Do you still need to use one of the borders of the board?
Yes. So the reason we combine those is because clip path is basically only available in the kind of evergreen browsers, so Chrome, Firefox, Safari. We, as government, still need to support Edge. Yeah, I think it does. Still need to support. I mean, we try to support IE8 still on our team. So, because there are so I think the general standard for government services is IE11, but we know there are cases where there are services with a user demographic that means they're more likely to be using older browsers like IE8. So we try and make sure that it can still use our stuff, essentially. But yeah, so that's the reason we combine both techniques, so that we cover kind of both bases.
A lot of your decisions are obviously driven by user feedback. What sort of format does the user research take?
As much as possible, it's sort of lab-based user research. So, which can be quite difficult. It's really difficult to recruit, especially users with access needs. We try really hard. In the past, we've done things like prototype entire fake services to put in front of people to try out new potential changes, things like that. Some of it does come through feedback from end users. One of the things we find quite difficult as a team is we're quite far removed from people who are actually using government services, so that can come through on any format. It's usually fed back through kind of teams or departments to us. And then there's usually a bit of kind of investigation and trying to work out what we do about it.
I'll follow up on that. So do you do like any metrics or sort of A/B testing on like usability of the websites?
Not within our team. I think the Gov.uk program, so they're the folks that look after the actual kind of the content, if you like, that report treasure page. I think they have done some A/B testing and stuff in the past, but I think generally we tend to steer more towards trying to get kind of lab-based user research.
Just to feedback on that point about the user testing as well. I know a team from Gov.uk Pay went to a user's house very recently, 2 or 3 weeks ago, to actually observe him paying for it as well. So that's something. Only 2 people, but they do that as well.
With consent.
One more question. What does success mean to your team? How do you know
That's a
whether
very broad question.
right, but how do you know what you built is the good thing that you built?
I think it's more about continuous improvement. So recognizing that there's always room to make things better. We're always getting feedback, which can sometimes be hard to balance. Like, as an example, there are people who really struggle with high contrast websites. Gov.uk, pretty stark, like almost, it's not actually black, it's not quite black, it's nearly black. White is not perfect for those users. The more we push in one direction, the more we might negatively affect someone else. So we're constantly kind of trying to balance all of these considerations. In terms of kind of having the confidence to ship stuff, I think a lot of that is about manual testing. We're lucky to have access to a lot of the kind of the assistive technologies, so we can try different, like that spreadsheet you saw, we can evaluate different alternatives. I think when we're doing that, we're always trying to be mindful that we are not really users of those technologies, and it's quite difficult to understand how, for example, like how verbose someone using a screen reader wants the website to be. Like, are they happy at actually exploring and finding things on the page themselves? Because I think that, you know, we could make it so that whenever you navigate to a page, it starts reading the entire page to you automatically. That's not default behavior, very much desired behavior. So we need to find that balance. But yeah, we do rely a lot on kind of user research and evaluating things like that. Cool. Okay, thank you very much for your time.
I think we'll have a short break if anyone wants to grab a beer or drinks or anything like that. So
Happy to chat. As
yeah,
well.
and totally. Cool. Thanks, man. That was wicked. Cool. Wait for Matt to take a seat.
Take a seat.
Cool. So next up, we've got Mike. You might recognize Mike if you work here, or if you're not. The thing I'd like to point out about Mike's talk, which I just noticed just now, is that up here it says FEN, which stands for Front End North. So it's not actually for this meetup. Just no, it's like I've actually seen this talk about 4 or 5 times now. Every time I kind of like learn something a bit new about it. So and good things as well.
So it's not flawless.
yeah. I'll let you know how I feel about it afterwards. But thank you very much for giving me a talk here. It's great. Cheers.
Just to counter Ben's point, just before this started, a colleague upstairs described this talk as me ranting about testing again. Just to like drop expectations a bit, it's a bit more like that. So yeah, like Ben said, I'm Mike Smith. I'm going to be talking about testing this evening. So when I first thought about this talk, I really hoped it would be like one of those really cool BuzzFeed headlines, like this one crazy trick lets you deploy at 4 p.m. every Friday. But to be honest, after I wrote the talk, reviewed it, did it to Ben 4 or 5 times, it's a bit more like this well-known approach means you can probably have slightly more confidence deploying, but you should still probably not deploy on Friday afternoon. So I kind of apologize for the disappointment in advance. So yeah, like Ben said, I work here at Oxbotica, working on web tools for autonomous vehicles. And there's lots of really interesting challenges around autonomous vehicles in the web. So for example, how do we render millions of points of LiDAR data in the browser? But what's a more interesting challenge to me is how do we test that we can render millions of points of LiDAR data in the browser? And nowadays, I would really like that challenge. It sounds really interesting, but I've not always felt like this. Back when I finished university, I thought testing was a waste of time. All my code is perfect because I've got a degree, obviously. We should just ship it all 100% all the time. And then I got my first job. They were really keen on testing. They kind of enforced TDD. And I started to kind of get into this idea that testing is a pretty cool thing. And as someone who still is pretty nervous hitting deploy, here was this thing that gives you this confidence that you can actually hit deploy and it's going to work when you ship it. But after a while, I got a bit of false confidence and learned kind of the lesson that actually just writing tests isn't enough, and you have to write the right tests. Otherwise, you give yourself false confidence. So we're going to look for a little example about how that can happen. So let's pretend that first company I worked for was like a calculator app company. Obviously, calculator examples are the most exciting examples to use in talks. And let's say we had this story to implement the subtract function in our calculator. So I go away, I write my code, I write my tests, and my product manager comes to me and says, hey, or I go to them and say, hey, let's ship it. And they say, it's Friday afternoon, it's 4 p.m., this probably is a bad idea. And I say, no, I've written my tests, they've got 100% coverage, everything's passing, we should 100% ship this right now. I go ahead and ship it because tests are passing, that's perfect. I go home for the weekend. When I come back in on Monday, my inbox is full of complaints. So we thought we can go and review the code, review the implementation, and see what's going on. So we have a look at it, and a few things aren't quite right. So the function just returns 2. We've lost the ability to type 0, and we've used Comic Sans, which is probably the worst crime about this whole thing. So what went wrong? We did write tests, got 100% coverage, everything passed. So the problem is here, we probably asked ourselves the wrong question. We probably should have asked, have you written the right test for that? But that's actually a really difficult question to answer. In the world of testing, there's now so many different types of testing available. It's really difficult to know at any one time what the right thing to use is. And of course, in the web, for each one of these, there's probably 20 different JS frameworks to implement it. So it's a really hard decision of what to do at any given time. But the good news is people have worked on this to come up with ways of knowing what tests to write. So if we go back to 2012, a guy called Martin Fowler came up with a testing pyramid. And this tells us for kind of a standard web app, how many of each different type of tests we'd expect to write. So at the bottom of our pyramid, we've got our unit tests, and these have the negative that they're really isolated, they're just on a single unit of code, but they're really fast, fast to write, fast to run, so we should write quite a lot of these in our application. And then at the top of the pyramid, we've got our UI tests, which are really integrated, they run over the whole application, but of course they have the negative, they're much slower, so we should probably write a lot fewer of those. But obviously, being in the web, we kind of do things a bit differently sometimes. So in 2018, a guy called Kent Dodds came up with the JS testing trophy, and the idea was to kind of readapt this to the web. So at the bottom, we've got our static type checkers. So we have things like TypeScript and Flow now, and these will kind of catch a lot of the issues you would normally find with web applications. And then most of this stays pretty close to the pyramid, but the middle is where this differs. So in the web nowadays, most of us, I imagine, are using frameworks like React, Angular, or Vue. And when we're writing components in those frameworks, we're actually writing an integration between our JavaScript code and the DOM. So the most tests we write for the web should probably be integration tests. And at the top of our trophy, again, same as the pyramid, we've got our end-to-end tests, the kind of gold standard tests that we probably shouldn't write that many of, but cover the whole app in one go. But these two formulations only tell us how many of each test to write, and not which test to write. So I thought I'd sit down and try and work out when I'm writing a test, what is it that actually go through my head at any given time. So this is what I came up with. So for me, the right test at any time is the cheapest test, which gives me confidence, stability, and documentation. So what do I mean by these three? So first of all, confidence to me means if those tests pass, I should have confidence that that code's going to ship and work. Stability to me is two things. So the first thing, those tests should ideally not be flaky. So that's often a symptom of maybe using too high-level tests for something you're working on. But also, if the implementation changes, but the functionality remains the same to the user, that I don't have to go and write those tests again. So I don't keep going back and change those tests every time something small changes. And then lastly, documentation. So I'm not the biggest fan of comments in code, but I think tests are the best way of documenting something because it documents its behavior and what you expect it to do. So what do I mean by cheapest? Cheapest is the quickest to write, quickest to run, simplest to write, and that runs on the cheapest resources. So it's all good me coming up with a little waffle about what goes on inside my brain. We've got to look at how we'd actually implement this in practice. So to do that, we're going to look at adding a feature to an example application. So not only do I like testing, which makes me a really exciting person, I also really like stocks and shares, which is a bit of a taboo topic at the moment. But so at home, I've been building like a little personal project to kind of search for these things and kind of watch them go down mostly at the moment. And not only do I like stocks and shares and testing, but apparently also I use Jira for my personal projects, which is just really cool. So let's say we're working on a story to implement search functionality into our application. So we've got 3 bits of acceptance criteria here. So the first thing is, as a user, I'd like to be able to search for stocks. The second thing, as a user, I'd like to be able to view price data for the stocks. And then lastly, as a user, I'd like to be able to navigate to view details about the stock. So if I was given a task like this, I'd want to split it down into the kind of component parts that make it up. And the first thing I want to do would be to implement the function that actually goes and does that search. And when we're talking about writing a function, we're talking about writing unit tests. So as the name suggests, unit testing is testing a single, like really isolated unit of code. They're super fast to write, they should be super fast to run. But even though that's true, we can do things to help write our unit tests a bit better. So I like to structure my unit tests like this, the given when ends. So the given is like a setup of the test. What do I need to be true for these tests to pass? The when is where you actually do the test, you call your function. And then the then is where you do your assertions. You maybe check that you get a specific object back, and you check that that function has then gone and called another function in turn. So we can apply that to code like this. So this is the function that goes and makes that call to go and search for those stocks. So if I was going to go and write some tests for this, I'd want to break it down into each component part so I could document all the behavior. So firstly, I'd want to test my actual request. I want to make sure I'm requesting the right URL with the right search parameters. Then I want to check what happens if it goes correctly. What happens if all my data comes back? Does it all transform it nicely? And then lastly, what happens if everything goes wrong? Do I get the right error text back, and does it all handle that correctly? So we can translate that first example into the given when then structure. So given I want to search for a stock, when I search for Apple stock, then it should request Apple stock from the search endpoint. So if we translate that into some code, it looks a bit like this. So in my given, I mock my backend. In my when, I then make that function call. And then in my then, I expect the request to be made to the right location. And what we can do is we can then go through and add the rest of the tests for the rest of that function. So if we go back to our original checklist and see whether we should be writing these tests, do these give me confidence? Well, they are testing every pathway through that function. So I feel pretty confident that no matter what happens, this is probably going to do what I expect. In terms of documentation, these are documenting, again, exactly all the behaviors I expect that function to do. And the backend's mocked, so it should be pretty stable. There really, ideally, shouldn't be any kind of flakiness with these tests. So I write my function. We can go and have a look at how the application looks at this point. So I can search for Apple. And we get some data back from the backend, which is pretty neat. We get a few of it back, but the last two, the modified and created data, haven't quite worked correctly. So even though all my tests passed, everything looked good, I checked that the data was transformed correctly, something hasn't gone quite right here. And what's happened here is, in our test, we assumed we had a contract with the backend. We thought the backend would supply data in a specific format. And then when we've deployed the application, it's gone through and the backend has changed the way it's working. And we can use tests to help prevent against this. And when we're talking about contracts between front-end and back-end applications, we're talking about contract testing. So contract testing, like I say, is the idea that we as kind of web application builders have contracts with our services, and we expect them to behave in particular ways. And of course, sometimes the data that our services provides change without us knowing, and everything fails in production. So with contract testing, we can try and guard against that. So what we have to do is define a bunch of contracts that we expect to be held. So we say for a specific endpoint, I expect the body to come back in this format. What our contract testing framework will do then is it provides us with a mock service. And every time we run our tests, we hit that mock service rather than the real backend. But every time it does that, it then goes and hits the real backend and checks if that data is coming back in the right format. And then if it doesn't, it will fail and let us know that something's going to go wrong when we deploy this to production. So if we go back to our original checklist, this is not the cheapest thing to do. It takes a lot of setting up. If you're iterating over stuff often, you're going to have to keep updating the contracts. But there's a couple of places where this is probably a really good use. If you are in a massive company, hundreds of teams, lots of microservices, obviously, ideally, people would kind of talk to each other, which would solve this problem. But that often doesn't happen. So this is a really nice way of just giving yourself a little bit of confidence that actually, things aren't going to change when you deploy. The other thing is, if you integrate with a lot of third-party APIs, again, ideally, they'd send you an email or something nice like that, but these things don't happen. And this is just that extra confidence that your contracts with your backend API is going to work when you ship stuff to production. So we can fix our contract with the backend. We can look at our really exciting app, and we can go and search for Apple stock, and we get some data back in the right format. Everything's fixed. Everything's looking okay. But at this point, this is pretty horrible. This isn't useful to anybody. There's just a bunch of text on a page. So we want to start actually rendering some stuff in the DOM that's useful to users. And as soon as we're talking about rendering stuff in the DOM, we're going to start talking about writing integration tests. So like I said, integration test is the idea we're testing an integration between something. In this case, we're testing between JavaScript and the DOM, but it could be between JavaScript and Redux or different APIs. It depends what integration you're testing at any given time. So these, similar to unit tests, are pretty cheap to write. They're pretty quick to run, but it is still good to do some things to help write better integration tests. So the first pattern I've seen quite a lot, which I think is a really nice pattern for writing integration tests for components, is to kind of write these kind of 3 tests for a component. So first of all, the happy path. What happens if my component has all the data it needs when it needs it? What does it look like? Second of all, the error state. What happens if my component doesn't get the data it needs when it needs it? How does it handle that? And then lastly, the loading state. What happens when my component hasn't got the data it needs yet? What does it do in that circumstance? Another question that comes up quite often is mocking. Some people don't think you should not mock anything, keep it as real as possible. Some people will go, you should mock nothing. Now, the risk with mocking is obviously if the thing you're mocking changes its implementation without you knowing, your tests are going to pass even though in reality they're not going to work. But if we go back to our testing trophy at the start, if we're using static type checkers, things like TypeScript and Flow should pick up that these things are changing and let us know. So we can be much safer about mocking these days than we used to be able to. So my personal opinion is mocking is really good. It helps you focus your integration tests on just that integration you're testing and not all the other bits of code surrounding it that you don't need to test again. So again, with integration tests, we can use given when thens to structure them. So for example, here we would have, given we have price data for a given stock, when the search result is rendered, then the price and daily data is rendered. So if we look at that in code, it almost looks identical to our unit tests. So given here, we set up using Firebase here for data, so we mock the Firebase. In our when, we then we do that integration. So we mount our here a React component on a virtual JavaScript-based DOM, and then our then we expect different bits of data to be rendered. This is fine, it works, but it's a little bit verbose. If I change where that price is, I have to go and change this test again. If I change the charting library I use, I've got to go and change this test over and over again, which reduces that stability and makes it a bit more painful to write these tests. So we can do something to make these a little bit more stable, and what we can do is snapshot testing. So this is something that is in jest. I don't think any of the testing frameworks have this yet. But the idea here is when I run this test, it renders the DOM output of that component to a file next to your test. If that DOM output changes, it will then tell you, hey, there's a difference here. You need to approve or decline this. So this has the benefits that you don't have to keep updating your tests. You just have to approve or decline the snapshots. But it has the mega con that it actually relies on us all being like really diligent and checking the snapshots have actually changed the way you expect. When I imagine, well, at least I just hit update and just accept the changes, which is not the best thing in the world. So if we go back to our original checklist, again, integration tests like on the trophy, we should be writing loads of these. They give us a lot of confidence our component is behaving the way we expect to. They document really well every pathway through your component. And again, we're mocking our backends, we're mocking all the data, all the things that are non-deterministic. So these tests should be nice and stable. So we should definitely be writing these tests at this point in time. So we've written our integration test. We can render our component, and it looks like that, which is really great. So at this point, we haven't got something rendering to the DOM. Our tests are valid, they passed. We've got our price, we've got our graph, which could show anything, but it looks pretty terrible. And this is another thing we can actually solve with testing. So when we're looking at testing how things look, we can use visual regression testing. So this is the idea that for any component you're building, any page you're building, there's like a gold standard version, the version you expect your component to look like. What we do is we take pictures of that and we store it in some visual regression testing service. If I go and make changes to that component, what I do is I re-render it, upload a new version of that screenshot, and pixel by pixel compare the two and see if anything's changed. So we can have a look at what that looks like here. So this is an example using the Percy framework. Here's my original version, which looks with some lovely purple and green colors. And here's the new version here. And what I have to do, similar to the snapshot testing, is I have to go through and check these and approve whether I think they are correct or not. And there's some really nice extra benefits to this as well. It will let you check things in different browsers. So here's it rendered in Chrome versus Firefox. And it also let you render it in different browser sizes. So it's a really useful way of testing how things look cross-browser and responsibly as well. But it has the same negative of snapshot testing that I, as a developer or designer, have to go in here and manually approve or reject this, which adds a lot of extra kind of overhead and time to the process. So yeah, again, if we go back to our checklist, this is quite an expensive thing to do, literally financially an expensive thing to do, unfortunately. The really good visual regression testing framework's quite expensive. Percy is like $30 a month for the cheapest plan. And I think the one that Storybook makes is hundreds of dollars. So this is financially expensive. It also takes quite a lot of time to set up. You've got to have a storybook with all your components rendered individually. You've got to upload them all the time, and you have limited amounts. So it takes quite a lot of time to do, but there's a couple of use cases where I think this is super beneficial. So if you're building a component library, this is a really good way of guaranteeing your components look correctly, particularly if you're really interested in responsiveness cross-browser. So you might have quite used to it. The other case is obviously if you have an app which needs to be really mobile, responsive, and work cross-browser as well. It's a really good way of giving yourself that extra confidence that little changes don't break things in kind of lesser used browsers. So we can go and fix our design, well, fix-ish our design, and have a look at our search now. So we can search for Apple stock, and hopefully everything looks a bit better now. So that's okay, we can search for stock, we get a result back, but this is just a component isolated on its own. It's not really useful to anybody where it is. So at this point in my story, I want to start integrating with the rest of the application. And as soon as we talk about integrating stuff with the rest of the application, adding it into user journeys, we're talking about wanting to write end-to-end tests. So end-to-end tests, as the name suggests, are testing your application end-to-end. So everything from the front end to the back end, the servers, the databases, everything in one go at once. And these are kind of renowned for being flaky, for being painful, and for failing tests for no reason because animation didn't finish on time or whatever. But there are things we can do to write better end-to-end tests. So the first thing we can do is use the page object model. So the same guy who came up with the testing pyramid invented, that's probably not a word, but came up with the page object model for end-to-end testing. And the idea here is you abstract your pages into classes which represent the structure of that page. And what this means is if you change a class name, change where something is on the page, you don't have to go through every single one of your tests and change that selector or that path, that ID. You just change it in one place and then every test is automatically updated from that. But we can go one step further than that and we can use data attributes on our elements. So here we're using a data test attribute on our search input. And what this means is no matter where that search input is, no matter whether it's a div or a text area, wherever it is in the application, as long as that data attribute is on that element, our tests are going to keep passing without having us to go back and keep re-implementing and changing the selectors around. So with end-to-end tests, they're kind of the exception to the rule on the given when thens. And quite often in end-to-end tests, you'll have assertions at the beginning, in the middle, at the end, preconditions, all kind of things like that. So when I'm running end-to-end tests, I like to see them as kind of a user journey. So here, for example, we've got, as a user, I want to be able to search for a given stock, view its price data, and navigate to a page to find all the rest of its data. So we can then convert that into code. So one of the other benefits of the page object model is this actually writes our tests a bit like a story. And this has the benefit, if we go back to our calculator example at the start, if I share this with a non-technical person, maybe a product manager or a project manager, they can actually read through the test and actually validate themselves that I've not just written a load of nonsense. So here we've kind of got search page, enter search query Apple, expect the search result count to be 1, expect the price chart to exist, click on the search result, and expect the new page to be rendered. So this is really beneficial for actually sharing the knowledge that your tests are actually doing what you expect them to do around the team. But even further than that, hopefully this will play. Depending on the test framework you can use, you can actually record these test runs and distribute them as well. So you can attach these as even more evidence that your tests are actually doing what you expect them to do. So that's pretty cool. If at this point we kind of want to stop there, I have done everything in the story. It works as expected. I can search for stocks. Everything's looking okay. And if I was just building this for me, that would probably be okay. But as we just saw in the last talk, if you're building for anyone but yourself, you have to kind of think about other people's needs. So what I thought I would do is run this through a screen reader to have a little bit of a listen to what it sounds like. Hope this is going to play.
Shape header.
Oh, no.
Shape header. Edit text. E. $APL.
So this is pretty appalling. So not only did it not actually tell you that it was a search box or what you were searching for, when you got results back, you have absolutely no idea what you got back. So it's completely useless to anybody who has any kind of accessibility needs in that case. And we can actually use some forms of testing to help us with that. And specifically here, I'm talking about PayPal's automated accessibility testing tool. So what this does is you feed it the raw kind of HTML output of your page, and it will run tests against it and generate a table of all the issues with that page. So for example, here we've got things like color contrast, we've got things like elements not being labeled correctly, and then you can use this to help fix those accessibility issues. So if we go back to our checklist again at the start, this is actually surprisingly cheap and easy to do. This took me like half an hour to set up, so it's kind of a bit of a surprise we don't do this more often. I haven't seen this used very often, maybe that's just me. In terms of confidence, it doesn't test everything. It's not going to find everything. There's probably still a lot of manual testing to do if you really want to be truly kind of accessible. But in terms of giving yourself that little extra boost that you're building kind of inclusive web applications, this seems like a really nice and maybe not a well enough used way of kind of helping yourself identify accessibility issues in your application. So I can go back and I can fix those, and we can take a look at the application now. So far we've been looking for Apple, which is pretty boring, so we go a bit further afield and look for Nintendo. So even though our end-to-end tests are working, we've written all our tests up to this point, we still got an error in the application. So we got two options at this point. We could debug it, use the debugger, work through, try and find where the error is. But I don't really like doing that. I'd rather write more tests. So at that point, we can use some tests to test our tests to try and find out where things have actually gone wrong here. And if we're talking about testing our tests, we can use mutation testing to do that. So mutation testing is the idea that we let a bunch of mutants go and kind of run wild in our code. And they're going to go in there, they're going to change plus to minuses, times to divides, they can delete code, change conditionals, true to false, and all kinds of things like that. And it's our job to exterminate them. And we exterminate mutants by our tests failing. If our tests fail, we found that mutant, we found the change in the code, and it means our tests are actually working properly. And in a world where kind of code coverage maybe is given a little bit more emphasis than it needs to be in kind of test quality, this is a really good way of actually testing how good your tests are and whether you're actually really testing what you think you are. But how does this actually apply to the bug we saw there? So we can take this function, for example, called stock prefixer, which takes a stock and the exchange it's listed on. What it does then is it then prefixes with its location. So if it's in London, prefix it with London. If it's in New York, prefix it with New York, which is pretty simple. Our test looks pretty decent. If you pass London in, prefix it with London. If it's New York, prefix it with New York. It all looks pretty simple. It's documented. Everything looks okay. So we can then run this through our mutation testing tool. And we can see that although we killed 9 of our mutants, one of those mutants survived. And what that mutant did is it went in and changed that second conditional to be a true. And then the test still passed. But how does that how does that go back to our bug? So if we look at this function up here, if that second else if is changed to true, both our tests will pass. London will return London, New York, New York. When we went into our app and searched for stock that wasn't there, that was in Japan, Tokyo, this function would return undefined. And then somewhere in our application, we've tried to manipulate that, use it, and it's fallen over trying to do something with undefined. So mutation testing is a really good way of kind of validating how good your tests are, but also it can be a good way of finding bugs, although probably the debugger would have been a quicker route to do this than what I did, but it's fine. So again, going back to our checklist, this is it's quite easy to set up, but it's a little bit flaky, so it's quite a kind of expensive thing to do, I suppose, in terms of time and what you get back out of it. In terms of confidence, if you're writing an application that really needs to be super correct, you really need exact preciseness, perfect testing, this is a really good thing to do. But I think for most people, this probably is a little bit overkill. And you'll probably spend more time getting really annoyed at this than you're actually writing code or application. So at that point, we can go back, we can fix our bug, and hopefully we can now actually search for some Nintendo stock. We can go through and visit our page. Everything looks like it's working now. So in summary, the 3 things I hope I've got across with this talk is that we should divide and conquer with our tests the same way we do with our code. So we shouldn't try and write every kind of level of test all at the same time. And this doesn't mean don't do TDD. You can still do TDD as you go, but kind of write the right tests at the given the right time. Second of all, try and find the cheapest test possible to give you the confidence to ship your work. If you spend ages investing time in end-to-end tests for a really small thing, you'll get quite frustrated when it fails. So try and find the cheapest way possible that you can feel confident that what you do is working. And last but not least, everyone has different requirements, everyone has different things they're trying to do, some more complicated than others. And no matter what it is you're trying to do, no matter how specialist your requirements are, there's always something out there to help you gain that confidence. We saw accessibility testing, mutation, visual regression, all things which are probably not traditional forms of testing we're all used to. But there's always something out there to help you gain that confidence to ship your work. Thank you very much.
Has anyone got any questions or?
Do you use PercyIO at the moment?
No, I don't. I used to use, I think it was called Casper.js, I think, previously, which was an open source one, but it finds a lot of false positives. I think the paid for ones are much better at kind of actually finding the real issues with design changes, whereas the free one's not. So, yeah, the only way I could actually get this set up was to have it open, kind of open and public, which isn't really ideal. So, yeah. Chromatic looks really good, the storybook one, but they don't even have a free tier as far as I can tell. So.
When the function that you're testing uses a library that is not under your control, how do you know how to mock that service?
That's a good question. I suppose if you're using a library, I guess you just have to mock the function calls that you know you're making from the code you're testing. I suppose in Jest you only have to kind of mock individual functions within that library you're using. So I guess you just have to mock only the specific functions you know about. And hopefully, if that library has types and using a static type checker, it should pick up those changes if your mock doesn't match what's going to happen in reality.
Right.
Would it be possible to do contract testing on regular plugins, as in not over network? Or would that work? Yeah. Actually, if you had like a proxy, between like the library that you're using and then track calls between that, would that work?
Yeah, you could do that. I mean, if you want to do that, you could do that.
Yeah.
What's the question?
I guess questions like how to ensure you're testing external third-party libraries that you're using in your own code base.
Yeah. So for example, if one of my things reads from an SQS, obviously, I don't want to test whether the Amazon SDK SQS bit is correct, because that's Amazon's thing. But I want to know the things where the SQS read the thing correctly, read the thing incorrectly, and these are all different and wonderful ways how the SQS can fail.
Yeah.
Or just not available.
I suppose it's the level of integration you're looking for. So if you're on if you want to test a bigger integration of your app, not end-to-end with SQS, there are, I think it's Boto, I think, will provide mocks for like Amazon Web Services and will generate those for you. If you're just testing your code, unit testing your code, at that point I would probably write an adapter for SQS and just mock that level out of my own code and mock that bit. I guess it depends how high level you're testing it at any given time, like how you mock it.
And I've got a question. What do you reckon is the best way of ensuring that as a project progresses, we stay good at testing it? Or I find that stuff I've worked in the past is like I'll write a lot of tests at the beginning, but then as it kind of carries on, I'll get like less and less good about that.
Yeah. So I think one of the cool things to do in that case is every time you find a bug in an application, write the test to find that behavior before you fix it.
Yeah.
And then you at that point, you're kind of testing the important things first and you don't get frustrated. Yeah, like you say, you write loads of tests at the start and you give up because things are probably going okay.
Yeah.
And when they start failing, start writing the tests for the things that are failing and going like that.
Cool.
I guess also TDD sometimes.
Yeah. Cool. All good. Cool. I guess we're done. So thanks. Thanks, Mike. I was like, thanks everyone for coming. Thanks to our two speakers as well. That was good. It's been really nice having you here.